Okay, so I want to warm up with number 2 in section 1.2. And what they're asking for is, yeah, they're asking, is it increasing or decreasing? And maybe more appropriately, where or when is it increasing or decreasing, right? Okay, so let me see. When's it going up, guys?
Between the 0 and the 1, X.
Oh,
When
yeah,
X is less than 1.
for sure.
Yeah, that's not the right way to say it, but.
Yeah, so it's definitely going up between 0 and 1. Is it going up over here?
Yes.
Yeah, I think it's also going up over there. So the kind of weird thing is like, okay, so like, that's increasing, right?
Yeah.
Okay, but how do you actually write the answer? Okay, so you might write x is smaller than 1, increasing. That's cool. I'm down with that. Why are you raising your hand, Jeremy? Just talk.
Well, I said that like between like negative and infinity and 1.
Okay, another way you could write that is minus infinity to 1. This definitely gets an open bracket, right? Okay. Yeah, parenthesis, right? Open bracket. What about this end?
Because it looks like it goes to 1, I would assume it'd be a bracket, closed bracket, but.
Yeah, so this is where we get philosophical here. Right there at the top.
Is the constant times?
Yeah, it's kind of flat, right? So it'd be a little weird to say it's increasing there. You guys see that?
Yeah.
Because really what I would mean if it's increasing there is I would mean if you go to the right, you go up. Right? But right there, if you go to the right at all, you go down. So I'm going to go with an open parenthesis here, and that actually matches our intuition that we used for the first phrasing anyway. Right?
Because X is just standing in for a number that we don't know.
Yeah.
Okay.
You guys good with this? It would be vaguely within keeping of our definition to say that it was actually increased. No, it wouldn't. Never mind. Forget it. There's a point you could argue. You'd probably be wrong. Where is it decreasing?
When X is greater than 1, it's decreasing.
Okay, when x is bigger than 1, like over here, right? Okay, which you would write as interval notation, how?
1 to infinity.
1, comma, infinity, open parentheses on both?
Yes.
Pretty good with that? Okay, what is it at 1? Yeah, I think the way I have this written, I have neither. You guys see that? Because 1's not actually included in this interval, and 1 is also not included in that interval. Right, so I would say at 1 it is neither increasing nor decreasing because it's kind of flat there. You guys see that? Okay, we should contrast that with something just slightly different. Contrast. Make my cubic more cubic looking. It still stand to be more cubic looking. So if this is x cubed, right? X cubed does actually kind of have a flat spot in the middle there. Right? But what's the difference between that kind of flat spot and this kind of flat spot?
Is there more than one number?
No, it really is just at one number. It's just at 0.
You still increase.
Yeah, it's still going up across that thing, right? So on this one, I think you'd say it's increasing from minus infinity to infinity. Basically, there's just a little bit of thinking you got to do at a flat spot, right? And actually, we're going to have a tool in calculus class for finding flat spots, and we're going to spend a lot of time talking about flat spots. right? Why would we be interested in flat spots? Well, oftentimes we're interested in kind of maximizing functions, right? Like we want to maximize our profit, or we want to minimize the amount of aluminum that it takes to build an aluminum can, right? You guys see that? Like those are problems we spend a lot of time asking, like what's the best, way to do this, or the best object I can make, or the best whatever, right? So whenever you ask a question about like what's the biggest or the smallest or the best or the optimal, you end up asking a question about where are the flat spots and how can you find them. Cool?